Good afternoon. This is as part of the 153rd annual meeting of the National Academy of Sciences, we have this highlight event, which I know is appreciated and enjoyed by everyone in the audience. The auditorium is pretty well filled. We also are webcasting the event to many members and friends around the world, actually. We'll be hearing from many of them, we hope, with favorable comments. They're very impressed. In presenting these awards every year, we generally hear some very, very inspiring accomplishments, or at least a brief glimpse of them. And in the citations that will be presented about each of the individuals and the reason for the award, I think we will be further inspired. And it always reminds us, too, of what goes into these major accomplishments. Clearly, in almost every case, there are very supportive individuals, whether they be institutional, family, friends, but behind each story of major accomplishments, there are always those stories. So I hope that you will enjoy it. The awards ceremony booklet is good to follow if you get a chance. And I'll make one announcement that the nominations are now open for next year's prizes. We take a lot of time doing these. In each prize that will be presented today, there will be a representative or a leader of the selection committee who was involved in making the selections, and they work very hard because these awards are quite competitive. So we do encourage as many nominations as possible. Don't be put off by the fact that they are very competitive, but please submit nominations. The first prize that we want to award has become an annual event now in honor of our former PNAS editor, deceased Nick Cozzarelli, who was a wonderful editor of PNAS. So for each of the Academy's 6 classes, we present an award each year on what was judged to be the most outstanding paper in that class of science. So the first one, I'd like to announce those winners and just ask a representative or two or the entire research team that wrote the paper to stand for recognition. The prizes were actually awarded at the PNAS editors meeting earlier. In physical and mathematical sciences, for the paper Mimicking the Magnetic Properties of Rare Earth Elements Using Superatoms, Sibo Chang, Junate Berkdemir, and Will Castleman. Are any of the authors here? Okay. I know those authors, and it was quite an accomplishment. In biological sciences, Sadish Ramakrishnan, Eric Anderson, Angelica Martin, Brooke Centofanti, and Yatrik Shah for the paper Maternal Intestinal HIF-2 alpha is necessary for sensing iron demands of lactation in mice. Are any of the authors here? Thank you. For Class 3, which is Engineering and Applied Sciences, the authors are Evgeny Filipov, Tomohiro Tachi, and Glaucio Paulino for the paper Origami Tubes Assembled into Stiff Yet Reconfigurable Structures and Metamaterials. Thank you. And in biomedical sciences, for the paper Evidence for Alpha-Synuclein Prions Causing Multiple System Atrophy in Humans with Parkinsonianism. And the authors are Stanley Prusner, Amanda Warman, Daniel Mortis, Joel Watts, Ryan Rampersad, David Berry, Smita Patel, Abby Oler, Jennifer Lowe, Stephanie Kravitz, Daniel Geschwind, Daniel Glidden, Glenda Halliday, Lefkos Middleton, Steve Gentleman, Leah Greenberg, and Kurt Giles. Let's give them a hand. In each case, there are thousands of papers published annually by PNAS, so these award winners really have tough competition themselves. In Class 5, Behavioral and Social Sciences, for the paper Rising Morbidity and Mortality in Midlife Among White Non-Hispanic Americans in the 21st Century by Ann Case and Angus Deaton. You there? And finally, in Class 6, Applied Biological, Agricultural, Environmental Sciences, the paper Low-Cost Solution to the Grid Reliability Problem with 100% penetration of intermittent wind, water, and solar power for all purposes. The authors are Mark Jacobson, Mark DeLucchi, Mary Cameron, and Bethany Few. Let's give them a hand. Now I'd like to introduce Dr. Neil Garrels, who is a member of the selection committee for the James Craig Watson Medal. Neil?
My pleasure today to announce the winner of the 2016 Craig Watson Medal. And this year it's awarded to Timothy M. Brown. Tim is at the Los Cumbres Observatory Global Telescope Network, and the citation reads, "For his visionary scientific and technical achievements that have been critical to the field of helioseismology, astroseismology, and the emerging field of spectroscopy of transiting exoplanets, and for his critical role in helping a new generation of scientists to succeed." I wanted to add on a personal note that our selection committee was very much impressed with the accomplishments of Tim, and I'm honored to present this medal to him.
I may not thank everybody who deserves it, so I'm only going to mention two organizations and one person. The first organization I want to thank, of course, is the National Academy, for reasons that should be, obvious. Next comes the High Altitude Observatory, which was the organization where I worked for most of the years during which the work cited here was done. And its director for many years, Michael Knolker. When I went there, the observatory was an enclave of solar astronomers in the much larger National Center for Atmospheric Research, which was meteorologists. So the day that I walked into Michael's office and said I needed money to look for transiting extrasolar planets, which is neither of those things, he was entitled to say, Tim, don't be an idiot. Why don't you go do something that at least smells like our mission? But he didn't do that. He thought for a minute, he slapped his desk, and he said, I will support this. And he did. So that took judgment, and it took nerve, and I'm grateful for both of them. So thank you, Michael, and thanks everybody for listening.
Congratulations again. To introduce the John J. Carty Award for the Advancement of Science, I'll call on Edward S. Buckler, the chair of the selection committee.
So So it's my honor to present the 2016 John J. Carty Award for the Advancement of Science. It is awarded to Theodorus Mawusen of the Norwegian University of Life Sciences and Michael Goddard of the University of Melbourne. So their citation is for the development of genomic selection, which is united quantitative genetic theory with genomics technology, and has been really revolutionizing genetic improvement of both livestock and crops. Their research has also invigorated the area of genomic prediction, which has far-reaching implications for the fields of human medicine all the way out to conservation biology. And on a personal note, I want to add that these are two scientists who've worked mostly in the cattle industry and in cattle breeding, but they've reached out through their generosity and collaborative nature so that scientists from all communities in genetics and applied genetics can now use these approaches, and they are being applied to hundreds of species. So thank you all very much.
Well, thank you to the National Academy of Science for this award, and I'd like to thank the collaborators on the paper that made us famous. Of course, that's Teo Mawusen and my colleague at home, Ben Hayes. And I better thank my wife for putting up with me for all these years.
When I went to Australia in the year 2000, it was mainly to escape the northern winter and enjoy the sun in Australia. But genomic selection turned out to be much more useful than that afterwards. I would like to thank my colleagues at the Norwegian University of Life Sciences and Wageningen University and Research Center, where I was working at the time. And many thanks to Ben Hayes and thousands of colleagues around the world who have been making this approach better and better over time. Thank you.
To introduce the Jesse Stevenson Kovalenko Medal, we'll have Professor David Ginsberg, Chair of the Selection Committee. David?
Well, it's my great privilege to introduce the winner of the 2016 Jesse Stevenson Kovalenko Medal, which is awarded to Huda Y. Zogby at Baylor College of Medicine. The citation reads that this award is for her pioneering contributions to the fields of neurodegenerative proteinopathies, autism spectrum disorders, epigenetics, and developmental biology by accompanying clinical observations and gene discovery with focused, in-depth mechanistic studies. Huda unraveled the molecular basis of spinal cerebellar ataxia and Rett syndrome. In 1999, she and her colleagues discovered that Rett syndrome is caused by loss-of-function mutations in the X-linked gene MECP2, which established it as the first autism spectrum disorder that's largely caused by sporadic gene mutations. She'd go on to demonstrate that the brain is exquisitely sensitive to the levels of this protein, which she termed a Goldilocks protein, and that doubling of its levels caused another devastating neurologic disorder among boys. Using mouse models, her team has recently identified potential therapies that could improve the debilitating symptoms of these syndromes, including learning, memory, and other cognitive functions. On a personal note, Huda is a spectacular physician and scientist and wonderful colleague, and I'm personally absolutely delighted at this award. Congratulations.
Thank you, David, and thanks to the Academy. I'm deeply honored to receive this award. And I must say, I won't be here today, however, if not for the patients who inspired me, the mentors who guided me, and the collaborators and trainees who provided the intellectual partnership and the sheer joy of the work. I want to especially mention the late Ralph Cicerone, who taught me clinical scholarship. And I thank Art Boudet, who taught me how to be a scientist. I want to thank my long-term collaborators, Harry Orr, Hugo Bellin, and Juan Botas, who've all become dear friends. I'm so grateful, actually, to all my trainees. There's one in the picture here, who have actually labored with me and laughed with me and made research absolute joy. Lastly, I want to thank my husband, William, who's been my partner every step of the way, in spite of navigating a busy and passionate career in cardiology. Our life with each other and with our two beautiful children has made my career in this award possible. Thank you.
The National Academy of Sciences Award in Molecular Biology will be introduced by David C. Page, who's the chair of the selection committee.
It is my great pleasure to introduce Diane Newman of the California Institute of Technology, the 2016 NAS Award in Molecular Biology winner. Diane. And the citation for Diane's discovery of microbial mechanisms underlying geologic processes, thereby launching the field of molecular geomicrobiology and transforming our understanding of how the Earth evolved. Diane. So just 1 minute of history. In 1660, a young Dane moved to Amsterdam to study human anatomy. On the side, he dissected the head of a shark. Traveling in the mountains of Europe, Niels Stenson identified sharks' teeth embedded in the rock, far above sea level. Recognizing these teeth to be fossils, that is, mineralized remains of ancient living organisms, Stenson conceived the idea of sedimentary rock and the superposition of sedimentary strata, thereby creating a new field of scientific inquiry, geology. If only Niels Stenson could be here today to present this award, he would marvel at the curiosity, the imagination, and the dedication of Diane Newman in joining anew studies of living organisms with the studies of rocks and minerals. Stenson would surely be amazed at Diane Newman's creativity in unearthing the roles that microorganisms have played as geochemical actors in shaping our planet, and especially its mineralized crust. Congratulations, Diane.
Thank you very much. This is a real honor, and I would like to thank the nominators and selection committee. It is really quite remarkable that this award is being given to a geobiologist, and I think that is a reflection both of their broad-mindedness and of molecular biology's power to transform other disciplines. So just to interject, it's important to note that geobiology really is an old field that is becoming increasingly important in the modern world as we seek to understand the complex interactions that sustain the biosphere as it co-evolves with the Earth. I never set out to become a molecular geobiologist, but it has been a wonderfully serendipitous journey. And I wouldn't be here were it not for my incredibly supportive family. I'm here today with my mother, my brother, my wonderful husband, and my son. My mentors, Francois Morel, a geochemist who got me started, and Tom Silhavi, who taught me the power of bacterial genetics, and truly phenomenal colleagues throughout my career. All of these people have launched and sustained me on my path with their encouragement and support. And in this image there are my students and postdocs, and they took a huge leap of faith when they joined my lab. And this award honors our collective work over many years. And so as I like to tell my son, and perhaps also to some of the other young ones out there I saw with lab coats on, I think it's important to note that this award is possible because together we dared to be different. So I thank you all.
The National Academy of Sciences Award in Scientific Reviewing, or for Scientific Reviewing, will be introduced by Professor John Hopcroft, Chair of the Selection Committee. John?
The 2016 National Academy of Science Award for Scientific Reviewing is presented in the field of computer science this year to Sergio Verdu of Princeton University. This is for his consistent and distinguished contributions of review material in information science and for a leading role in developing high-quality review journals covering broad areas of the information sciences. And the committee was just very pleased that we picked somebody who is an outstanding scientist as well as somebody who has contributed to the field in the area of reviewing.
Well, let me start by thanking the Academy for this award. It's in fact the first time that it goes to engineering and computer science. Let me also thank Annual Reviews for their generosity in endowing this award. And I would also like to thank Princeton University, which has been my intellectual home for my whole teaching career, and where I've had the privilege of working with amazing people. So review articles play a very important role evangelizing and bringing new fields to people from other disciplines, and especially important also for young researchers who are looking for new avenues of research. Also, I'm a firm believer that the history of the subject is crucial if you really want to understand a subject. So in my own research in information theory, I've always put a special emphasis in unraveling the different strands that go into new discoveries and ideas. And I would like to take the opportunity, I mentioned that I work on information theory. Some of you went to Google yesterday and found a nice doodle about Claude Shannon, who was the inventor of information theory, the father of the information revolution. His 100th anniversary was yesterday. So we're working hard throughout this year to bringing his amazing body of work known to the general public. So lastly, I want to thank my friends who are here today, Bin Yu, Elizabeth Cox, Dave Forney, and of course my wife, Mercedes Parache. Thank you.
The National Academy of Sciences Award in Chemical Sciences will be introduced by Monica Olvera de la Cruz, Chair of the Selection Committee.
I am honored to introduce Caroline Bertozzi, who was awarded the 2016 NAS Chemical Science Award. The committee selected Caroline for the developing of bioorthogonal chemistry, a technique that allows the development of new biotechnologies and imaging living cells in vivo. Caroline, the citation reads, for founding bioorthogonal chemistry and applying this novel chemistry to install artificial sugars on the surface of living cells, enabling the study of their roles in cancer and the immune system.
Thank you. Monica, that was fantastic. She was talking through it with me earlier to make sure everything was right and accurate, and I really appreciate that, and especially since you were on the selection committee, let me extend my gratitude to the committee members and also to the National Academy for a tremendous honor. And it's moments like this that one often takes stock in all of the people who were so supportive and basically helped me to evolve into the chemist I eventually became, starting with my undergraduate research advisor, whose name was Joe Grabowski, and this was at Harvard University in the 1980s, and I was a biology major and sort of contemplating switching to chemistry, and he encouraged me to do that. So thanks, Joe. The chemistry thing kind of worked out in the end, and then he was followed by my graduate advisor, Mark Bednarski, who really gave me a shot, which is the most any of us can hope for. And then he passed away at a relatively young age, so we lost him many years ago now, but I'd like to think that if he were still with us, he would be here in the audience. My postdoctoral mentor, Steve Rosen, also took a big risk on me because it was a time when there wasn't a very strong interface between chemists and biologists the way there is today. And I was a chemist trying to make my way into the world of biology, and a lot of doors were closed, but his was open, and so that was really an amazing opportunity. My colleagues at UC Berkeley, who were incredibly supportive to me and really gave me the career that I have today. I was there for almost 20 years, and my new colleagues at Stanford are fantastic, and I've been very fortunate to have so many wonderful, supportive people to work with. My students and postdocs, it all starts when you're early in your career with just a few people placing a bet on you. And you got to make it a good one. So some chemists joined my lab and were not deterred by the idea of doing chemistry on cells and in animals, and we had a lot of fun over the last few decades. And then finally, my family. I have 3 young boys. I think they're watching me by live web feed. Hi. But they're back in California. That's because their ages are 2, 4, and 7. If they were here, we wouldn't be able to get through this entire program. So, and my wife, Jen, who's holding down the fort with them, I would like to thank them for being so wonderfully supportive of me and for allowing Grandma to come and be here in the audience with me today instead of babysitting. So thank you very much.
Now we'll introduce the Troland Research Awards, and Marcus Reichley, the chair of the selection committee, will do that. Marcus?
Well, I'm very pleased to be here to represent the selection committee for this particular award, the Troland Award, which recognizes promising young investigators who have already made their mark and promise great things in the future in the area of psychology and neuroscience. So the first awardee is David Freeman from the University of Chicago. And the citation reads, for his innovative, experimental, and computational reviewing how neurons in the cerebral cortex support the representation of visual categories. What did he mean by visual categories? And he said the meaning of what we see. It is absolutely astonishing work, and we expect to see great things in the future. The second awardee is Jeffrey Woodman from Vanderbilt University, who is given this award for his artful blending of behavioral, electrophysiological, and neurophysiological techniques in humans and non-human primates to review neural communicants of attention, executive control, and memory, and his unique application of those techniques to individuals, humans, who have brain disorders, or offering great promise to be able to remediate these conditions. So to both of them, my sincere congratulations.
Thank you. What an honor to be here, and I'd like to thank the Academy for this recognition. As an undergraduate, I became fascinated with how the brain interprets signals coming in from our sensory systems, creating this rich conscious experience we have of the world around us, allowing us to learn, plan for the future, and make decisions. And it's been such a privilege to be able to devote my career so far to studying these basic fundamental questions. So I'd like to first and foremost thank the members of my laboratory that really have made all this work possible. Without them, I certainly wouldn't be here today. And also my graduate and postdoctoral mentors, Earl Miller and John Assad, who both provided such shining examples of creativity and rigor in science. And most importantly, I'd like to thank my family, many of whom are here today. My parents were my first science teachers, and they worked really hard when I was young to help foster my interest in science and technology as a child. And lastly, and maybe most importantly, my wife Constance and her wonderful family are also here today. We've been together a long time, since I was a graduate student, and she's been with me through all the ups and downs of science, rejected papers, tough grant applications, and all of these things. So it's really a great honor. Thank you once again.
All right, thank you, Dr. Rakel and the Academy. This was an exceedingly low probability event, 10 to the negative eighth or something. My grandmother, who passed a couple months ago, when she was growing up on the reservation in Oklahoma, she probably didn't imagine this kind of incredible honor from an incredible organization like this. But wait, it gets better. So I only got into one grad school, and I'd like to thank my friends at the University of Iowa, Steve Locke, Tom Spalding, for giving me that shot. Marvin Chun and Jeff Shaw at Vanderbilt thought I'd be capable of doing 2 postdocs at the same time with both non-human primates and humans, and I'm really grateful to them. Since day one, my department at Vanderbilt has been like family and supported me at every turn. as other people have noted, this is really an award for my graduate students, postdocs, my collaborators who did the real work and bet on an upstart junior faculty member when they had better options. In addition to collaborators, paper reviewers, program officers, and editors of journals have helped me at every turn, including my friends in the field. And finally, Ashley, Sam, Hunter, Paige, and Henry, the now famous people in the lab coats over there, help keep me silly, remind me what really matters, and ensure that I really only control any variables in the laboratory. So, thank you all.
Now I'd like to introduce Dr. Larry Squire, representing the selection committee for the Academy Award in Neurosciences. Larry?
The National Academy of Sciences Award in the Neurosciences is awarded to Mort Mishkin of the National Institute of Mental Health for fundamental contributions to the understanding of the functional organization of the primate brain, including discovery of the visual functions of inferior temporal cortex, the role of the dorsal and ventral visual pathways in spatial and object processing, and anatomical descriptions of cognitive and non-cognitive memory systems. In a research career spanning more than 60 years, all at NIH, Mort Mishkin charted the cortex of the non-human primate. He's been a friend and colleague for generations of neuroscientists, and on a personal note, the best kind of scientific rival. Mort?
You'll have to excuse me, I'm a little nervous. When you've done nearly 70 years of neuroscience, as I have, you owe an awful lot of people an awful lot of gratitude. More to the point, I didn't earn today's award all by myself. I did it with the help of a huge list of supporters. Starting with my scientific heroes and mentors, I have to quickly add all of my collaborators and colleagues, my associates and assistants, and my postdocs and my postbaccalaureates. Even that long list is incomplete. Also in this mix are my wife and family, all of whom root for me no matter what. I take this opportunity to say how grateful I am to all of you, all of who are in that long list. I couldn't have garnered the award without you. Thank you.
The Alexander Hollaender Award in Biophysics will be introduced by Hua Chu, member of the selection committee.
It's my honor today to present the 2016 Alexander Hollaender Award in Biophysics to Richard Henderson from Laboratory Molecular Biology, Medical Research Council, Cambridge, United Kingdom. Richard. for his pioneering work in the determination of atomic structure of macromolecule by electron microscopy. Henderson determined the first atomic structure of a two-dimensional protein crystalline array called bacteriorhodopsin. His identification of the key bottlenecks for obtaining high-resolution electron structures has guided subsequent efforts to revolutionize single-particle cryo-electron microscopy for structural biology research at the atomic level. On my personal note, Richard has always been very kind to many junior investigators in the field. I personally have been benefited immensely all this year with Richard's encouragement and guidance. Thank you, Richard.
So it's indeed a great honor. I'd very much like to thank the National Academy, the Committee WA, and Mrs. Hollaender for establishing this award. Having come from a physics background as an undergraduate and decided about 50 years ago to go into what I called then biophysics, which then kind of fell into slight obscurity, I think it's great that now biophysics is sort of re-establishing its impact. And I think this award reminds us both of Alexander Hollander's contribution and the continuing impact of biophysics. In terms of my own area, I feel more like a flag carrier for what the field that we call now electron cryomicroscopy than a particularly talented individual. There has been a lot of recent spectacular progress in cryo-EM, and this is due to the contributions of a lot of outstanding scientists throughout the world, actually, sort of Europe, USA, Japan. And so I feel really lucky to be a member of this community of very talented individuals. So many thanks again. Thank you.
The National Academy of Sciences Award in Early Earth and Life Studies in memory of Stanley Miller will be introduced by Jonathan Lenine, Chair of the Selection Committee. Jonathan?
It's a real pleasure to announce the winner of the 2016 NAS Award in Early Earth and Life Sciences, which this year is the Stanley Miller Medal. And this medal alternates with the Charles Doolittle Walcott Medal. In fact, each of these is triennial. This is only the second Stanley Miller Medal to be awarded, and it's awarded to honor exceptional research on the early Earth. So the 2016 Stanley Miller Medal winner is Professor James F. Casting of the Pennsylvania State University for his outstanding modeling studies of planetary atmospheres and habitability that constrain the environmental context for the origin of life. Now, Jim's work influences so much of our understanding of the early Earth that I'm only going to give you what I think is the most important aspect of it, and that is that he really revolutionized our understanding not only of why the Earth has remained habitable, but why neighboring planets have not been, and in particular why Venus went haywire so early in its history. And Jim as well gave us a kind of a time limit for the habitability of the Earth. We don't have the rest of the main sequence lifetime of the Sun. We have a much shorter period, as it turns out, thanks to Jim's work. So I'm going to keep... I'm going to keep my remarks short as a consequence of that. But I do also want to say that I've had a chance to observe Jim lecturing at schools around the world, and he presents his ideas so clearly that the students get it immediately, they absorb it,
and they're inspired by it. And so on behalf of the committee, it's a real pleasure to announce James F. Casting as the 2016 Stanley Miller Medalist. Jim.
Well, thanks, Jonathan, for that introduction. I hope I haven't made our time on Earth here any shorter by my work. I would like to start by thanking the National Academy for this award and for establishing this Stanley Miller Medal, which, as Jonathan said, now alternates with the Walcott Medal. I knew Stanley personally, and his work, pioneering work on the origin of life with Harold Urey, was one of the inspirations that led me to work in the field of early Earth and life science. I owe thanks to many academic mentors, and I'll not try to list all of them, but I will say that I got my start as a graduate student at University of Michigan. We had an outstanding faculty there, and one of the young research scientists at the time who was inspiring to us graduate students was Ralph Cicerone. So Ralph and I have known each other for a very long time now. After, at Michigan, I worked with Jim Walker and Paul Hayes on the long-term climate evolution of the Earth and the faint young sun problem. Then after that, I went out to NASA Ames and worked with Jim Pollack on planetary atmospheres, the runaway greenhouse effect. Jim Pollack was Carl Sagan's first graduate student, and so that was really an opportunity for me to learn about planetary science. That work evolved into studies of climate evolution on exoplanets around other types of stars. This diagram that's up there is one representation of the liquid water habitable zone around different stars, and today it's populated by various exoplanets, most of them found by NASA's Kepler mission. If those of you who were here yesterday for Sarah Seeger's talk heard about the long-term future where NASA hopes to directly image these planets and take spectra of their atmospheres. And so not only will we be able to test our theories of atmospheric evolution, but we may be able to find out if there's evidence for life in our corner of the universe. Thank you again, and let me thank my wife Sharon, who's in the audience, and all my grad students and postdocs without whom this would not have been possible.
The Pradel Research Award will be introduced by Gina Torrigiano, Chair of the Selection Committee.
It gives me enormous pleasure today to introduce the winner of the 2016 Pradel Research Award, Alex L. Kolodkin of Johns Hopkins University School of Medicine. And the citation for this award is for his pioneering work on neuronal development research relating to the establishment of neuronal connectivity. He's known for his work on neuronal guidance cues and their receptors, the discovery of semaphorins, and unveiling guidance cue roles in neural circuit assembly and function in insects and mammals. To put that a little bit more simply, perhaps, what Alex has really done and contributed to in a tremendous way is working out the molecular rules that allow complicated networks of neurons to assemble themselves into functional circuits so that all of your brains can function properly. And so, Alex?
Well, I'd like to thank the Academy for this honor. It's truly humbling to be recognized with the Pradel Award for our work in the area of developmental neuroscience. Our studies have really grown from the tireless efforts of the members of my laboratory, and this award really highlights their abilities and their insight. And further, the creativity and generosity of my colleagues in the field have really greatly facilitated our work and motivated me to really push our studies really every day. I'd like to recognize a few of my scientific mentors, Franklin Stahl, Corey Goodman, Mark Tessier-Levine, my first department chair, Solomon Snyder, and my current chair, Rick Huguenier. These scientists continue to inspire me to do the very best I can for my trainees and have been really inspiring mentors over the years. And of course, I would like to thank my family for their unwavering support in my career over many, many years. Understanding how neural circuits develop is fascinating, and it's also increasingly relevant in the context of neurological and psychiatric disease. And I really look forward to future work in this corner of the field. Thank you very much.
We'd like to award 2 prizes in psychological and cognitive sciences. And we thank Dick Atkinson and Rita for endowing these prizes. The first will be introduced by James L. McClellan, Chair of the Selection Committee. Jay?
So it's a tremendous honor and privilege for me to introduce John Anderson, who is one of the 2 recipients of the 2016 Atkinson Prize in Psychological and Cognitive Sciences. John has been a role model to me since I was a graduate student, and he was just barely out of graduate school at that time. John began making seminal contributions, integrating experiment and theory to develop models first of human memory and then of integrated architecture for cognition, publishing 2 very important books, one already in the 70s and another shortly thereafter on the memory and the architecture of cognition. He went on from these important contributions to pioneer the development of a rational analysis for cognition, helping us to see that our behavior is not just a product of the mechanisms of the mind, but of the task constraints that we must work within as we figure out how to think and remember and solve problems. Next, he applied the ideas arising from this work to the development of effective cognitive tutoring systems that have been adopted in many school systems, especially in the fields of algebra and geometry. Most recently, he has sought to seek the neural basis of the mechanisms and processes embodied in the theories that he's developed by using functional brain imaging, together with further theory development and experimental behavioral analysis of human cognition. So the citation itself couldn't cover all of that, but it does say that this prize is awarded to John for foundational contributions to systematic theory and optimality analysis in cognitive and psychological science, and for developing effective theory-based cognitive tutors for education. John.
Well, thank you, Jay. It's an honor to be introduced by you. It's a special honor to receive the Atkinson Award. Dick Atkinson was one of my graduate student teachers, and it turns out our work on cognitive tutors actually built on his early work that he had done on instruction. It's a special pleasure to have my 2 sons, Abe and Jay, in the audience. And my wife is here, the sort of emotional and intellectual partner for all my life.
And I just have one more thing I just can't resist saying, because we have one other connection with the Atkinson Award, and that is actually, well before I met her, my wife, Lynn Reeder, babysat for the Atkinsons.
And Susan Gelman from the selection committee will round out this pair of Atkinson Prizes. Susan?
It's really a great honor and privilege to award the second 2016 Atkinson Prize in Psychological and Cognitive Sciences to Carol S. Dweck of Stanford University. The citation reads, "For her groundbreaking work documenting that the implicit theories that people hold about human abilities and traits have profound consequences for their perseverance, resilience, and achievement." And I wanted to say that Carol's work has fundamentally changed how we think about human self-regulation, academic achievement in the school setting, and interethnic conflict. This is tremendously broad and applicable work. And one very small measure of the influence that Carol's work has, not only for theories of cognition and social psychology, but also for the world at large, is to look at the list of people that Carol has been brought in to advise, including school systems, governments, and the United Nations. So welcome. Let's join me in praising Carol for this.
My deepest appreciation goes to my extraordinary colleagues, a number of whom are here today, the most phenomenal of whom are here today, and to my husband, who very sweetly requested that I mention him by name. David. I'd like to honor retiring Stanford President John Hennessy, who created the most vibrant, adventurous, the most can-do intellectual atmosphere I've ever experienced. In that environment, people almost can't help having big ideas and pursuing them vigorously. And I'd like to express my profound excitement at being part of such a vital field, one that is using its scientific prowess for the public good. Of course, our field is about understanding basic psychological processes, but more and more of us are trying to use this knowledge to address important human issues and pressing social needs. Thank you, Dick Atkinson and NAS, for supporting this enterprise.
It's a great pleasure, and partly a personal pleasure, to introduce Professor David D. Sabatini, who will in turn present the Raymond and Beverly Sackler Prize in Convergence Research. David?
The 2016 Raymond and Beverly Sackler Prize in Convergence Research, presented in the field of convergence research that benefits human health, is awarded this year to Dr. Stephen Quake
from Stanford University. Dr. Quake is recognized for his innovative technological advances in the fields of microfluidics and genomics that have allowed the development of new non-invasive diagnostic procedures, which have allowed the detection of disease conditions at the level of one cell, of one molecule. And this has had immediate impacts in the field of medicine. Today, it is possible with these techniques conceived by Dr. Quake to really diagnose brain tumors or to detect the rejection of transplanted organs or to make the diagnosis of genetic diseases at the prenatal stage. It is really a great pleasure to congratulate Dr. Quake and to mention that this is the second Sackler Award that he receives. That in 2011 he receives the Sackler, the Raymond and Beverly Sackler Award in biophysics, conferred by the Israeli Academy. Dr. Quake.
I would like to thank the Sackler family for their generosity in endowing numerous awards, and which I seem to be the beneficiary of, but also for their greater philanthropy. It's not unusual to visit a school or university and find there's a Sackler department or faculty there, and they've been tremendous in support of science worldwide. I'd like to thank the students and postdocs who sort of accompanied me on this journey where we would blunder into new fields armed only with the hope that a few principles of physics would help us discover some new insights, and that's been a great journey, and I thank them for coming along with me on that. It's been 20 years now of doing that, so too many to go through by name, but they know who they are. And finally, I'd like to thank my children, Theo and Zoe, because it was their coming in my life and my becoming a parent and a father that created a very unexpected convergence of my personal and professional interests, some of which was mentioned in the citation there. Thank you.
And now I'd like to introduce Professor Susan Wessler, our Home Secretary, to in turn introduce this year's Public Welfare Medalist. And Susan will also describe a little bit about the significance of this award. Susan?
The 2016 National Academy of Science Public Welfare Medal is awarded to Alan Alda, actor, director, screenwriter, author, and science communicator. The Public Welfare Medal, which was established in 1914, is the highest honor of the National Academy of Sciences and is presented annually by the Council of the Academy in recognition of distinguished contributions in the application of science to the public welfare. The citation for Alan Alda reads as follows: for his extraordinary application of the skills honed as an actor to communicating science on television and stage, and by teaching scientists innovative techniques that allow them to tell their stories to the public. So I'm going to give a bit of a background. I have a little bit more time for an introduction, and Alan Alda, our honored guest, has a little bit of, hopefully a lot more time to speak to all of us. So Alan Alda is a native New Yorker. His acting career on television, film, and stage spans more than 5 decades. For 11 years, as we all know, he played Hawkeye Pierce on the classic TV series MASH, winning 7 Emmy Awards for acting, writing, and directing.
He also appeared in continuing roles on ER, The West Wing, and 30 Rock. He has starred in, written, or directed more than 30 films, including Aviator, for which he was nominated for an Academy Award. On Broadway, he received Tony nominations for Glengarry, Glen Ross, Jake's Women, and The Apple Tree. His role as science communicator is equally distinguished. As host of PBS's Scientific American Frontiers from 1993 to 2005, Alda interviewed hundreds of researchers about new discoveries in science, technology, and medicine. Alda also hosted 2 miniseries for PBS, The Human Spark, which explored what makes humans unique, and Brains on Trial, which examined how neuroscientific data from brain mapping technology could be used as evidence to inform the court system. On Broadway, Alda appeared in QED as physicist Richard Feynman. He also wrote the play Radiance, The Passion of Marie Curie, and Dear Albert, a reading for the stage of Einstein's letters. Alda's passion to help scientists communicate with the public led to the establishment in 2009 of the Alan Alda Center for Communicating Science at Stony Brook University's School of Journalism, where he is also an a visiting professor. Alda and the center have trained thousands of scientists through workshops and around the country. In 2011, Alda wrote a guest editorial for Science magazine that led to the Flame Challenge, an annual international competition through which scientists answer a question in a way that is most appropriate for 11-year-olds. Entries are judged by thousands of 5th and 6th grade school children around the world. And if you haven't looked at the website, I really advise you to. The questions that have been answered over the last couple of years, the first is, what is a flame? Then, what is time? What is color? What is sleep? And this year, it's what is sound? And they're really, really enjoyable. Alda has won numerous awards, including the 2010 Kavli Science Journalism Award, the National Science Board's Public Service Award, and the Scientific American Lifetime Achievement Award, and the American Chemical Society Award for Public Service. In 2014, he was named a Fellow of the American Physical Society for his work in helping scientists improve their communication skills. I'm going to end with 2 very different things. First, in addition to welcoming Mr. Alda, I also have the privilege of welcoming a significant contingent of his family. One of his 3 daughters, Elizabeth O'Heaney, son-in-law Bill O'Heaney, and granddaughter Eleanor, who Alan told me he calls Ellie. She probably calls herself Ellie. He doesn't have to. I also extend a very special welcome to his wife of almost 60 years, Arlene Alda, an accomplished musician, photographer, and children's book author. Her latest book is an autobiographic book called Just Kids from the Bronx, which caught my attention as I am a fellow kid from the Bronx, as some of you may be able to tell from my accent. Second of all, I had the good fortune to participate in an Alda workshop here at the NAS building in July. After that experience, I was curious to understand how he learned to communicate so effectively. To find out, I read his book, Never Have Your Dog Stuffed, and other things I've learned. And there on page 274, I found what I was looking for. And this is a bit of an extended quote, but I think it's worth it. At first, on stage and in life, I didn't really know what relating was. And listening was more a kind of waiting than anything else. I talk, and then you talk. And then I listen for when I get to talk again. But relating, I came to understand, happens not just while I'm talking. It also happens while you're talking and in between. When I started out as an actor, I thought, here's what I have to say. How shall I say it? On MASH, I began to understand that what I do in the scene is not as important as what happens between me and the other person. And listening is what lets it happen. It's almost always the other person who causes you to say what you say next. You don't have to figure out how you'll say it. You have to listen so simply, so innocently, that the other person brings about a change in you that makes you say it and informs the way you say it. The difference between listening and pretending to listen, I discovered, is enormous. One is fluid, the other is rigid. One is alive, the other is stuffed, like his dog. Eventually, I found a radical way of thinking about listening. Real listening is a willingness to let the other person change you. When I'm willing to let them change me, something happens between us that's more interesting than a pair of dueling monologues. Like so much of what I learned in the theater, this turned out to be how life works too. And relating is what Alan has brought to his 700 interviews with scientists, and relating is what he and his center teaches scientists to do with the public, the media, politicians, and young children. It is with my great pleasure to welcome this year's recipient of the 2016 Public Welfare Medal, Alan Alda.
Astonishing this honor is. To me, it's just, I hope it's probably astonishing to you too, but I want to explain a little bit of, first of all, I must say why I think this is so important, because not just that my name is on that scroll, which is really nice, but that it's a recognition of how important the communication of science is. I'm so glad that you're establishing this recognition. You really, the National Academy is working toward it. The project on trying to understand the scientific basis of science communication is one of your very important projects, and I'm so glad it's happening. But I must say, I must share this wonderful honor with the dedicated, creative, indefatigable team that makes up the Alda Center for Communicating Science. I'm so proud to be a part of that group. We've trained and worked with, in workshops of the kind you just heard about, 7,000 scientists, and many of them, some of them are in the room today, and it makes me very thrilled to know that. But let me talk for a minute about relating. A lot of people wonder why an actor would be interested in communicating science. And that's what it is. It's relating, which is probably the essential tool for an actor. The essential tool for an actor is not being able to remember all those words or to speak those words trippingly on the tongue. Those things are important, but really at its basis, the essence is to be able to relate to another person, another actor, so that what happens in that person's eyes, what happens in that person's voice, has such an effect on me that regardless of how much we've rehearsed it, it comes out in a different way. There's something spontaneous that happens that brings this moment to life. And life is what we come to the theater for. We don't come for information on how they figured out how the character is played. We come for life. Let me give you an example of how important I think this is. Because it's not something that only actors can do. We all can do it to our benefit. And I think that this relating that I'm talking about, that takes place on stage between actors, is really at the heart of communication. The very heart of it. And I'll give you an example of what I mean. A few days ago, at the White House Science Fair, a 9-year-old boy presented his exhibit, which was a replica of the White House and a wand for blowing bubbles. And he had ingeniously constructed these using a 3D printer in a special way. But after he showed his exhibit, he spoke with President Obama and he made an impassioned plea for an idea of his. How about, he said, how about if we asked children to advise the president on the best ways to promote innovation? And I thought that was touching. And what I thought was touching in addition to that was the president listened to him and said it was a good idea and that he was going to look into doing that. Because, and this is the part that was not just touching, but I think kind of important. He said, because understanding children's explanations of what interests them is a way to shape our STEM education.
The idea of listening to what somebody is interested in before you try to teach them something is an ancient idea, and yet it's still a revolutionary idea. My friend Steve Strogatz, who's a mathematician and an educator, has said to me a couple of times, you know, the trouble with a lot of lectures is they answer questions that haven't been asked. And here was President Obama wanting to know what the children's questions were. But actually, you know, it can go much deeper than that. It's not just what questions they come in with. But while we're explaining things to somebody, are we reading them? Are we really paying, are we relating to them? Are we seeing if they're getting it? Are we watching their body language, their tone of voice, the expressions on their faces? Are they getting it? Or are we just spraying information at them? Are they enjoying getting it? I think these are some of the most important questions we can ask. Because although it's true that if somebody's going to really study science deeply, really learn it, they're going to have to work hard at it. If we're introducing them to it, then if all we do is turn them away from it, turn them off, then it's not communication, it's excommunication. And we can't afford to turn people off because science is coming at us faster and faster now, and in greater and greater volume. And we have to understand it well enough to make decisions that affect our very existence. So I think it's very important to pay attention to the connection we have with people. That's why I was so interested in what President Obama did when he related to that boy that day. And that's how I got interested in this whole project of trying to make communication something personal, something between two people of the kind I talked about, where life happens, where something goes on between them. About 20 years ago, when I was asked if I wanted to be the host of Scientific American Frontiers, I took it really greedily because it was a kind of a selfish decision. I wanted to know more about science. I was hungry to know more about science. And I thought if I spend all day interviewing these scientists, I'll have a chance to really get it. Now, the amazing thing is, I actually did begin to get it. The reason I got it was because of this unusual way we had of doing the interviews. They weren't stock interviews. I didn't ask a question and then give them a chance to answer it to the camera, and then ask the next question with no relation to what they said, but just because it's the next question. I didn't do that. It was an open-ended, improvisational conversation, because my goal was not to toss them softballs that they could hit out of the park. My goal was to understand what they were saying, and I wouldn't give up till I understood it. I grabbed them sometimes by the lapels, and I don't get it. What are you saying? Tell me again. And something would happen, and if most of the time they responded immediately to that. But if they had been in lecture mode before it, when they saw that this person, this human being standing right next to them, really wanted to understand it, I saw the tone of voice change, the vocabulary changed, they were personal, they were really trying to help me get it. And we'd sometimes have to go through it 3-4 times till I got it. But there was a human connection, and they were so available to me that they were available, therefore, to the audience watching at home. And I think when I got it, they got it. So there was a real dynamic interaction that had some of this life I'm talking about. So when the show was over, I had this thought. I thought, what if we could help scientists achieve this open channel that we had during the interviews? If they could have that with their audience when they're talking to the public or whoever they're talking to. And I thought back on my own life, and I thought, what really gave me the ability to do that was studying improvisation. And I thought, what if we teach scientists improvisation? Not comedy improvisation, but the very basic, pure kind of improvisation that is concentrated on the connection between the two players. And then the hope was, if they got accustomed to this connection with the other player, the other scientist they were playing these improv games with, when they turned to an audience, they'd have that same connection. And we experimented first with some graduate students, and then with scientists, graduate students at Stony Brook University, and it worked. And now at the Alder Center, it's the basis of all we teach as we teach communication. First, we teach improvisation, but even when we're teaching distilling your message, getting it down to its essence, making people understand what the essence of it is and why they should care about it, or when we're teaching writing, how to write an op-ed piece, we start the writing classes with improv exercises because we want to reinforce the idea that you're not just spraying out information, you're actually making contact with another person. It's your mind and their mind. I want to show you an example of what I'm talking about. Because hearing it is not the same thing as seeing it. And by the way, doing it is even better. So if you get a chance to do this, please leap at it. It's amazing because you realize this is different from what it sounded like. It's not being funny and it's not being quick on your feet. It's connecting. So I want to show you a video of a young scientist that we worked with. And this video, this is two parts. First part was before he took 5 sessions of improv. And then speaking about the same subject after the 5 sessions of improv. But in between, we didn't coach him on changing what he had to say. Anything he says in both videos came out of him. But first, without just studying the improv, and then after. See if you see a difference in those 2 videos. You want to play the video for us?
So my name is Steven. I'm a PhD candidate in the Geosciences department, and I love geology because it allows you to go out and look at environments over time, like being able to go out and stand on rocks that represent, anoxic oceans 150 million years ago, or, the first biologic life a couple billion years ago. And I have the pleasure of working on the coolest rocks in the solar system. They come from Mars, and over time, Mars has been struck by asteroids, and eventually, over time, if you have a big enough impact, you can not only hit the ground, you can toss stuff up, move it around, but you can also eject it off the surface of the planet. Moves around in orbit, outer space, and eventually, Earth encounters that chunk, and the gravitational field of the Earth pulls it in, and it survives through the Earth's atmosphere, lands on the ground, and we found it. And by measuring the gas in little bubbles inside these rocks, we found that it matches not the gas you would find on Earth, but Martian atmosphere.
You see a difference? I see a tremendous difference. And the way he phrased it, the things he mentioned, the things he talked about were different not because somebody said, mention this, concentrate on that. It was because he was habituated to making contact and he wanted to make the best contact he could. The energy, the authenticity, the passion that came out was so interesting to me, and we need to hear that. One of the moments I love is when he says the fragment came through the atmosphere and it hit the Earth and we found it. Remember that? I love that because what improvising does is it not only makes you aware of what's happening in the other person, it makes you aware of what's happening in yourself. He didn't know he was going to say, and we found it. But he loved saying it, and we loved hearing him say it. There was an unexpected moment there. It's hard to take your eyes off somebody who's doing these unexpected things because they're alive to that moment and you're alive to their being alive. And we need to see that passion. We need to see that energy. We deserve to see it. Those of us in the public, because science belongs to all of us. Science is beautiful. Science is a great detective story. It's poetry. It's music. Not only the whales sing, gravity waves make the universe sing. We're entitled to be in on that story. But we don't always understand what scientists are telling us, we out there in the public, because we haven't spent our lives learning the lingo. We've had other things we had to devote our lives to. We've been busy learning other things. Some of us are in the arts. Some of us are in business. Some of us are in Congress. I was talking to a member of Congress once, and I was just pouring my heart out about how important the communication of science is. And he stopped me right in the middle. He said, "You don't know the half of it." Says, I was at a committee meeting once, at a panel, where there was a table and there were members of Congress on this side of the table, and on the other side of the table were scientists, and they were all asking us for a lot of money, and they were telling us what they were going to spend the money on. And the members of Congress were passing notes to each other that said things like, do you know what this guy is saying? Now, this is tragic. This doesn't have to happen. The reason it happens is that those folks on the other side of the table that day were suffering from something that we all, at one time or another, all of us in every field, we suffer from. And that's the curse of knowledge, which you probably have heard is starting to get more traction now, this idea. The curse of knowledge, it's a strange expression, because why should knowledge be a curse? It's good to have knowledge. But the knowledge is a curse when you understand something in such detail and such depth and in all its complexity. You understand it so well that you forget what it's like to understand it that deeply, and you speak a language that the person's just not going to get. But it's amazing how much, science is amazing to me, that with such a little bit of data, they can come to far-reaching and deep conclusions. It's wonderful to see that. And it really is, it's interesting how little has to be said. I want to show you something. Could I ask you to be a volunteer for something? Yeah, come on up. That's very generous of you, thank you. Come on up, yeah, come on. I wasn't changing my mind at all. Thank you. Hi, Nancy, thank you very much. Alan, hi, nice to meet you. Now, I'm going to show you something. You're going to be great. You can't miss it, so don't worry about it. I'm going to show you 3 songs. They're very well-known songs. And I got them here, but I got to find it. 1 second. Oh, here it is. These are very well known. Come on over here.
Can you actually read this?
No, I'll get it up so you can read it. Isn't this exciting? This is so great. It's here, don't worry about it. Okay, now I'm going to get it up in a minute. Wait a minute. That should be here. This is so bad. I'm going to whisper the songs in your ear. Okay. One is the Star Spangled Banner. One is My Country, 'Tis of Thee. And one is America. Oh, beautiful, spacious skies, Mm-hmm. Okay, now, don't say anything out loud. Don't hum. Don't say words. The idea is Nancy's going to communicate one of these songs to you. I don't know which one it is. She's going to pick a song. She's going to communicate it to you just by tapping the rhythm of the song. For instance, you can hear that, right? If it was Oh Susanna, it's not going to be Oh Susanna. If it was Oh Susanna, it would be Oh Susanna, but without the singing, right? Okay, so she's going to communicate the song to you, and you're going to forget it. Don't say it out loud. We'll ask you later. So, tap for us.
Thank you.
Okay, so that's a very well-known song, I suppose. I gave you well-known song. So, just roughly speaking, what percentage do you think of the audience will get it?
10. 2.
10 to 2. Not very many. How many people think you know, don't say, just raise your hand. 1, 2, 3, 4, 5, 6, looks like about 10 people. That's actually pretty good. And now this is very interesting. Your estimate was very close to what it usually is. This is a study started by a graduate student at Stanford about 20 years ago, I think. And it's been done thousands of times. Most of the time, probably because you're a very realistic person in science, most of the time, the average that they guess is 50% of the audience will get it. And I've heard it go as high as 80%. And all the thousands of times it's been done, the average is 2.5%. Thank you very much for showing that to us. Thank you. So here's the thing. When you're tapping out the tune and you're not delivering the melody out loud, the odd thing is it seems almost impossible for you not to hear the melody in your head. You have information that they don't have, but you assume they have it. This is all at an unconscious level. And that's the essence of the curse of knowledge, that you know something that you assume the other people know. And this is, I think, a really interesting demonstration of it, because the person tapping, in most cases, in your case, you were really sharp and you said 10%, maybe down to 2%. You really had it. You almost nailed it. But we're stuck with only getting a mere fraction of what we need to get to be engaged by science if all you tell us is the bare facts and you don't let us in on the melody. The melody is the story. The melody is the emotion. We need to hear that to be engaged by it. You know, in the Flame Challenge, the person who won the first year's contest wrote a song and did an animated video. And the song had all kinds of hard words in it, like pyrolysis and chemoluminescence. However, the song had a delightful, engaging melody, and the kids who reported back to us about that entry said, I love that song. I sang it all day long. It came through my head even when I didn't want it to, because the melody was so engaging. And I learned all these words, and it's my favorite song about pyrolysis. So please think about giving us the melody and the story when you tell us about science. Things are getting better. There's pretty much of a movement now around the country and around the world to make science communication at the forefront of what we're doing. But real communication, clarity, bringing clarity to the science that we present to the public, to funders, and even to other scientists. Because if we're not in the same field, two scientists not in the exact same field, sometimes not in the exact same lab, often use the same words differently or don't understand one another's concepts or processes. And it doesn't hurt to clarify it. I'm not talking about dumbing it down. We avoid dumbing it down as much as we can. Clarity. I don't think science has been hurt ever by too much clarity. So I urge you, this is so important to me, I hope you won't mind if I make this a kind of a call to action, because I think we're living through a kind of a slow burning emergency. And if you haven't devoted yourself in any way to making science communication better, I urge you to please think about that. Maybe join us in our effort to train in the long range, to train graduate students who will become the next generation of communicators. We train them while they're graduate students. We give them a practice at it all during their courses. And then when they graduate, they're not only accomplished scientists, they're also accomplished communicators. But we're also working, because it's an emergency, we're also working with senior scientists who are communicating now and who are often expert at it, but they know they can get better and they want to get better. And they do get better. It's a very exciting thing, because Great things can happen if we actually relate to the audience, if we listen to what they're thinking while we talk to them, if we read their minds, if we're present with them. But we have to be related to them. We have to connect with them. I'll tell you one last story before I end. I was on vacation with my family. We were in the Virgin Islands, and I was taking a walk with my grandson, Teo, who was about 6 years old at the time. And we're walking down this path that's gorgeous. We'd never seen the trees and the bushes and the flowers like this ever before. And at one point on the path, there's this skinny tree that we'd never seen before. It's a tall, thin trunk with spiky, sharp things coming out all up and down the trunk. It was amazing. And Teo said, "Grandpa, look at that tree. How did that tree get that way?" And I thought, oh my God, this is so great. He's asking me about evolution. So we sat on the ground, and I explained as much as I could to him about adaptation and natural selection. We talked for 45 minutes. It was glorious. And the next day, he was swimming with his cousin, and he asked her a question, and she said, "You know, that sounds like a science question. Why don't you ask Grandpa?" He said, "I'm not making that mistake again."
Thank you so much. Before we adjourn to the garden party, which is just off the West Court, it will be under a tent today, so just to the west. Let's have one more round of applause for our award winners today. Thank you. And thank you. I understand that Alan Alda and his family will be here for a little while in the garden party, just a short time, but thank you.